你韓國嗰邊話開始咗？
係啊，個書名已經開始咗㗎啦。個書名已經開始咗㗎啦。
你聽住呢度嚟講。
Hi everyone. I'm from Hong Kong 01. I'm Dick. Let me introduce myself. I'm from Hong Kong 01. SRE team. I'm a team lead. I'm more familiar with big data analysis and cloud native infrastructure, and I'm also an open source contributor and advocator. Before I start, I want to promote. So we will introduce the technical aspects of Kubernetes. If you're interested about Hong Kong 01 and the relationship with Kubernetes, you can join the AWS Summit Online Hong Kong on the 7th of July, and I will join force with AWS architects to explain the relationship between Hong Kong 01 and Kubernetes. And I would lay out the agenda here. I will review Kubernetes, container, and some kind of reminders. I assume you have certain understanding of Docker. I will explain what's GitOps and why GitOps is needed on Kubernetes. An introduction to Flux CD. And most importantly, our hands-on session with guidelines. In our coming 1 hour, we will do a trial a Flux CD. And there are preparations. Before we move on, please prepare the below. You need a GitHub account because our instructions need GitHub. You also need a VM on multi-task, hosted on DigitalOcean, and we also need a Ubuntu 18.04. I will explain the installation later, but please prepare before. And also 2 GB memory. And you need a 30 GB. I will do a step-by-step guideline after explaining Kubernetes. And I have explained how to use multipass online. And you can see the notes here. And here's a link. And it takes some time to do the installation, so it needs some preparation. And here's some popular VM managers. So please prepare as you listen along. And you can download multipass if you need VM manager. And you can go to DigitalOcean. If you need to draw your credit card, then I won't instruct you. And here's the link on the notes. As you prepare the VM, I will explain what's container. And before I hands-on, some background are needed. What's container in Kubernetes? I assume since you're here, you know already. Container is a popular, or Docker is more popular currently. is a lightweight VM for some. Technically, is a C group isolate processor. We won't dive in now. Basically, it's a lightweight VM. Kubernetes is the most popular Docker orchestration platform, or to simplify, a Docker on cluster. How to put Docker to cluster traffic. Kubernetes handle many issues that Docker doesn't simply ignore. For example, how to ensure containers have higher abilities and simultaneously running. The details you should have already known. It's just a review of basic Kubernetes concepts so that later you won't feel too alienated from the concepts. So this flow is a concept flow. So this rectangle here is a container or a Docker. So usually your Docker runs on PHP and it's a lightweight VM. On Kubernetes, it is not the most fundamental unit. It should be pod, and it consists of multiple containers. In the most basic form of the machine, you won't just have Apache or PHP. There are other log collections or system monitors. In Kubernetes perspective, the most basic unit is pod. You have sidecar or other assistant containers. The smallest unit is pod. Scheduling or shifting process would be done by pod. Or the most simplified form, in one pod there's only one container, but usually there are multiple. Building on this concept, there's also replica set. In one pod, you have PHP or Apache. MySQL is not inside usually. Then it can self-serve to external pod. For example, you have to serve a web traffic, but sometimes it will hang. For example, the pod or container runs a physical machine that broke. Then you have the replica set concept. In the perspective of Kubernetes, you can maintain a certain number of pods. For example, running 5 pods, if one broke down, then you can still run it. It's the premier abstraction. And then you have the deployment concept. So for example, your code is in the container and you are ready for release. In Kubernetes or Docker's perspective, you won't go inside the container. Usually, the pod should be immutable, and you won't fix it all the time. So on the deployment side, it maintains the new and old versions as consistent. So that when you are making decision, then the old pod would open up new versions of pod. And deployment is a common concept that emerges. And lastly, the service concept. So it handles the external communications. For example, the pod handles the web traffic with load balancer, So service is all similar to load balancer as a entry point for different ports. And lastly, the namespace is an abstract concept when all the ports and services are under the same namespace. For production environments or test environments, you are deploying all these deployments and duplicate one version. In each definitions of concepts are in YAML files. In a Kubernetes store, this YAML all conflicts are realized in this YAML. So there's this template. For example, you have some services or there are few infrastructure between two websites. Then we have a tool called Helm. It's a package manager. And when you're using Dev or Ubuntu or Fedora, then you will use YUM. In Kubernetes, you have Helm. You can wrap the web application with Helm. It's used by data engineering like Airflow, so it can easily deploy to Kubernetes. So here, Bitcoin. So this is an overview of Kubernetes. So a kind reminder, if you have any questions, you can open the link of OSCon. There's a Q&A session, and we will abstract the Q&A questions and answer them. Proceeding was GitOps. GitOps, by definition, is the system should be declarative system. So they are described declaratively. So when you are using Ansible, when you're building a system, so you are teaching the computer step by step to build a web server. For example, installing Apache or PHP services, you have to teach the computer step by step. The declarative description means you don't have to describe the process. You just lay out the end goal. The benefit is that the deployment says it all. If it is not declarative, each process might have collapse or overwrite. Then you cannot estimate clearly. GitOps methodology requires the whole system to be declarative. Kubernetes is also YAML objects are all in the system, and it reveals this description. And the system stage should be versioned in Git. So even if you're changing versions or you're releasing a new version, should be stored in Git or have a version in Git. So similarly, Kubernetes YAML objects should be tracked in Git, and you just have to adjust it in Git. If the changes are applied to the system automatically, if you use Kubernetes, you have dual conflict or in earlier stages, you need SSH to do the server. In GitOps, all these changes should be done automatically. Manual adjustment shouldn't be required. Lastly, your system dates could clash on Git, and there's divergence. The system should be able to detect your desired system state. If there's inconsistency, the system should be able to detect them. It is required by GitOps. You might have heard of CI/CD and continuous delivery. In development process, we write the code and then we put them in code repository, and then through continuous integration to build or test, and lastly push. In Docker, we will push to Docker repository. For GitOps people on the other side, we will update the desired Kubernetes state and update to repository, and we will open a new pod for web server and pull and execute. So it differs from CI/CD, which is mainly for dev. And we apply it and change it to a production environment as a method. Then why GitOps? Why don't I just use tool control? Why don't I just connect to Kubernetes and open a new pod? But when you think about it, you have a server and have new SSH. You cannot manage them. In old times, you just make a singular server into a huge cluster. You shouldn't use that much, that often if you configure all YAML in Git, it will become a single source of truth for Kubernetes clusters. There are many benefits. For example, you don't care about the state of it for new onboarding colleagues. They don't have to understand the different versions or wrap them. You just deploy through Git. It's easy for new onboarding colleagues. Now Kubernetes is a bigger machine for all stages. You shouldn't treat it as a cattle or pets. The difference between cattle and pets needs intensive care. You shouldn't put intensive care for cluster, because cluster should be a auto stand boot. And if you need it, just open one, and if you don't need it, just shut it down. The primary reason is that Kubernetes doesn't need constant upgrades. So the period is around 1 year. You might not want your production cluster to do upgrade. Sometimes you have to open a new cluster and upgrade the new version and transfer the files from old cluster to the Kubernetes cluster. When you're doing discuss learn recovery, and there are complicated issues behind, then you will have a problematic state. Then you need single source of truth to config all things in Git. When issues arise, you just duplicate a new cluster and put everything in. So the design now, you can push all conflict in Git instead of cluster. That's the benefit. So after GitOps and Kubernetes, in reality, what are examples? FluxCD is one tool that we are going to touch on, where Kubernetes can run. FluxCD is a GitOps Kubernetes operator. It's a commercial product. It was later on open sourced, and now under Cloud Native Computing Foundation. You might not be familiar with it. For example, it's like a Cloud Native Container World's Apache Foundation's accumulation. It's under Linux Foundation. One of the functions is that it has multiple projects. Is the Apache Foundations for the Cloud Native world. Kubernetes is now under CNCS, and there are many Prometheus projects that are modern and Cloud Native on this foundation. From this flowchart, one of the essence of GitOps Git is here, a repository. We will use GitHub as an example. When some applications or applications are in repository, for example, your application, web servers, Nginx, container, in this process, whether you're a developer or not, you need to push your Docker image of the application and deploy new version of your Kubernetes container image and commit the conflict in Git repository. And the function of FluxCD is keep pulling the Git repository to know what are the adjustments and apply respective Kubernetes image and apply them. And they will store all the metadata in main cache. When applied to Kubernetes, there's this etcd key value store to maintain Kubernetes states, and is something internal to Kubernetes. You don't have to deploy any control command. You just apply the control Git. Then you can manipulate. This is a simple way to run. When you are making adjustments, you just need 2 commits. I will introduce them later on. More on Kubernetes Docker cluster. We have mentioned different definitions, including pod deployment service. In the later stage of Kubernetes, there's this customer resource definition. There's abstraction of different Kubernetes abstractions. For for example, load balancer. They allow developers to develop their own YAML object and allow developers to read their own objects and change respectively. For example, this YAML object, there might be one Kubernetes cluster YAML objects created, then this CRD object, it will realize a Kubernetes object automatically. Of course, there are many monitors behind, but with this function, Kubernetes can exceed the role of a container operation platform, but become a configuration hub for modern cloud-native infrastructures. And of course, depends on the vendor whether they can do it, but it allows the possibility. And in the future, it will become mainstreamed as a managing environmental and infrastructure. I could have touched on ham release to there's the CRD to do ham release, but it depends on the time. I might touch on it again. I won't go through everything. I won't cover when I'm deploying the containers. And if I install WordPress to Kubernetes, then I need my SQL username. I have to write in username and password and how to store them. The best practice shouldn't be key tags and stored tokens of password to repository. Please keep in mind. In this session, we won't touch on this. Please Google them yourself. We won't cover many other things. So don't think this is a all-rounded introduction. Before we proceed to hands-on session, Hong Kong Silver Run is now hiring. So on the left-hand side, we're hiring engineering positions. If you want to become our colleague, please go to this link and apply. On the right-hand side is a tech blog for Hong Kong 01's colleagues to release from our data scientists. We will share skills on machine learning and data science. If you have any questions, you can raise before our hands-on session on this link. Let's see if we have any question here. You can ask question here. Let's hold on for a moment, for 2 minutes, and see if there are questions. So if there aren't any, then please open the notes for hands-on session, and we will have different stacks covered in these notes. We'll guide you through them step by step, but we won't proceed to bonus session. Mainly we will cover the VM and GitHub account that you prepared and introduce how to install Kubernetes. We adopt KVS K3s is developed by Venture. It's a lightweight Kubernetes. It requires minimum 1 gig RAM memory, and you can also store some applications. And the design can be applied for edge computing, for windmills, for monitors for electronic windmills. Is one of the scenarios that is suitable for our practice today. And we will teach you how to install respective tools for repository and FluxCD, and we'll try out our FluxCD. Let me reconfirm if there are no Q&A. All right. Let's go through the steps. In each checkpoint, you can always raise your questions. Firstly, I assume you have installed the tools, so I won't go through it. Let me assume that you have a pre-installed multipass. It's a good command to manage your VM. If you have Ubuntu VM, it should be enough. And if you are using Mac, then you just need this command line. If you are using Linux, then it only supports professional or higher versions. If you are using Windows, then I can't help you currently, or you can build a VM yourself. I will open a new VM now. Let me build my VM now. I use Ubuntu 18.04 2 gig memory and open a 30 gig disk for FluxCD workshop. And depending on your network condition, if you are using the first time, now there's a local cache copy. You just need to copy for 1 to 2 minutes. To facilitate, we have a IP here. I will copy the IP now for later scenario. After you open your VM, you just enter this command and get the shell to do sudo root, and you are the highest rank administrator. Now, I assume you are all set. If you do not want to install locally, then you can build one on DigitalOcean, but you might not want to go through the registration. You can access via this link, and that's $10 credits, and then you can open a VM here. It's called Droplet in the perspective of DigitalOcean. So you have 2 gig RAM and you run to 18.04, and I selected Singapore as the region because it's closer to home. if you really need to do it online, then you might not need SSHD, just simply use password. I assume you have the machine ready. Let's connect it to the VM. Let's run this command to install the K3s. K3s is a lightweight Kubernetes. It really depends on the network accessibility. We will connect to GitHub and then download it real time. So it depends on the venue's Wi-Fi. It takes some time. While we're waiting, I will review K3s solution. It is a simple, friendly tool. After installation, you have ARM version 7 and ARM 64. You can even install on Raspberry Pi. Of course, it requires more memory, like latest 4 GB or 8 GB memory. But on K3s, to a certain extent, it applies to these scenarios as well. Voila. So we finished downloading and we will execute it. So it's on. Let's test whether it is ready or not. Give it a command and it's ready. It means you should know that they have checked the KPI cluster. The node on this machine is ready. To facilitate the execution later, we'll install the two config and we will copy down the installation config. So we have a Kubernetes cluster that is ready through K3s. And we install all the respective tools to install Fluxcd. We need to control command. The Ubuntu control command, the default command is not friendly, so we install another version. We use Ubuntu snap to install. If you need to install themselves, then here are some manual steps if the Ubuntu package manager doesn't work. Gladly, the environment at on-site environment is quite fast. I will fill in all three commands in one sentence. If you don't have VM, you can install it right now. Oh, I have an error in the last command. Let me fix it now. We need to add sudo. Okay, we have installed all the tools necessary. Confirm. We use kube control command to see if our node is normal. And go to the bundled ports. We have installed load balancing tools and building K3S Kubernetes assistance tools. We will install FluxCD now and prepare repository before. So it's a conflict of one of the config in our for upstream, and later you can use this repository to allow your Kubernetes cluster fix accordingly. Just fork it out now, we will use it later. Now entering FluxCD setup, we will use ham to install this time. So we add FluxCD ham chart repository and use the URL that we mentioned just now. And as I forked to .hub is an organization on GitHub and copy it here. You can enter your GitHub username and I'll open a namespace for Kubernetes and you can use ham the command. I fill in the username here. The repository should be this path that you can use. It won't apply to all Git repository, only namespace and workloads. Other folders, it won't monitor. It's not finished installed yet. It just applied to all objects. I want to know what's going on. I will use a Kubernetes tool that I developed myself to monitor the states. And this tool is Lens. I wrote a technical blog on this. Let's review. It is already deployed in ham command flux. A pod that is produced and it is fixed. We still need to run the command to get a SSHD public key because Flux will attempt to use SSHD key to access repository, because since we don't have it, we'll add the key to the repository you must check allow write access because it will write in the application process. So you must check this box. After you do that, it will post the repository every 5 minutes, but we will command Flux to reveal the update. Yeah. Let's wait for a moment. So after this phrase is shown, it is ready. All the above code are applied to cluster. And I missed something important. If one namespace is generated, this is a newly generated in 26 seconds before, is applied through Flux configuration, and when we review the repository in namespace, there's this namespace. In the folder of namespace, there's this demo. This new generated namespace is provisioned by Flux. How can we allow system to have respective conflict change? Let's access this folder in import info deployment. Let's copy them, and then if you're using command line, then you can fix them, adjust them locally. But here I will demonstrate clearly. Workload is now monitored. It's a monitored folder. We'll paste the deployment code here. Usually you will open a new PR for review and accept and merge, but because of time, we'll just commit it. And we have a YAML podinfo deployment here, right here. And Flux CD will detect the change and it will operate itself. So usually it's done every 5 minutes, but due to the time minute limit, we will apply it immediately. It will generate the demanded ports. Now it's ready. You can use review through command line. So you can see the image is kick-started now. Do you have any question at this point? You'll see the deployment says 2, so there are 2 files here. We'll pause for a while for your questions. So since there are no questions, after we have deployed the pod, at backstage, let me conduct one more action. Something will be shown here. It's not abstract pod, but it's web service. So let me deploy the service. While it is applying, this is a Fluxity feature. So there is a commit here because they detected an external pod info data image, and it will execute deployment to leave a commit release in Git. So it's in the last section of our notes, the continuous delivery. When there are change of code, then it will optimize the container repository. So this command skip a lot of steps. So there's this activity of pod forwarding. This is a result of the deployment. The pod info is a web service to a pod versioning. It is a tool that facilitates demonstrations. Now the pod is deployed. So our action earlier is not playback estimation abstract. So we still have some time. We can go through what we left behind. So sometimes it's not friendly to prepare the deployments. There's this space called Ham Hub. You can install external packages. I will install it skipping a lot of steps. We'll install Ghost. It's a CMS system similar to WordPress to install in the Kubernetes. And we need to install it through Fluxity. It involves installing Ham operator, so it store all the relevant so I won't touch on these commands currently. It will read the version of our release and deploy it on a ham. I have all the charts ready. You just go to release and goes YAML. This container version is suitable, and there are resources allocation or MySQL or Maria DB are all here. You just copy the whole file to your workspace, workload, and create new file. And commit. It detects the change. Then we can already have a sneak peek whether it is operating. And you can see it is deployed already. The ghost is in demo's namespace. And go to the namespace demo, and whether ghost is on, because we are in a VM. We can try port forward it out. It takes a while longer. And we need to download Ghost and MariaDB image. While we are busy, this IDE that I'm using is called K8s Lens. It is the most powerful Kubernetes IV. It's the best that I have used. So this is the one I'm using now. If you like command line, then you can use it and run the command line that you like. Though command lines are not necessary. Oh, some bug is happening. Let's check out the container. Now it's running. It should be able to port forward. Let's see what we have actually deployed. Ghost. Let's review them. Let's check out the logs. It takes a while longer. We are adjusting to connect the MySQL and configure it. I was too hasty just now. Now we can check out the log and open admin side. You don't have to be too hasty because the benefits of decorative method, you describe what you want, and at the back side it takes some time, so it's a derivative process. If you want a Ghost ham release, then you need preparation behind, so don't estimate that command line is once for all. It takes 1 to 2 minutes, so you need to be patient. Where it's up and running, the Ghost deployment is here. It takes 5 minutes. If you want to see other applications, you can go to Ham Hub and see other applications that can be applied in your cluster. So this is the finale of our sharing today. So that's about it for our session today. Do you have questions? No questions. I'll be here. You can raise any question any you have. Thank you all for attending. Thank you for attending this workshop. And lastly, Hong Kong 01 is still recruiting for engineers. If you want to become our colleague and come, please scan these QR codes. And if you're interested in our tech team's work, go to this tech blog and read our technical sharing. Thank you all.